In this video we'll show you how we can apply the adaptive machining techniques to a wireframe or DXF file. So this is the DXF file that's been imported. So to apply a toolpath to that, we go into the Advanced tab here, and the option that we want is for wireframe geometry. And from the pull down list here we're going to do 2D roughing, and we're going to use user defined features. So this allows us to set the curves or the contours that we're using as pockets or bosses. So we'll add a new feature. Okay, and that becomes a pocket. Now we add another one, which we'll choose this one here, and that becomes a boss. So that's selected the geometry. The tool we want to use, we'll use a 20mm end mill, and the height will start off at 0 and go to -15. The type of cutting that we require can either be offset, parallel, or in our case we want the adaptive, and we'll set the number of slices just to a single slice. In Z, if we want to, we can put in a number of slices, or we can choose a discrete depth. And then the stepper over here, let's have say 10mm. Okay, so that will produce the tool path for that shape. It's really quick and it's really simple to do. The standard method of approaching and plunging in is a linear one. If we want to change that, we go back into the operation, and under the roughing tab we can set linear, helical, or automatic. If we choose automatic, the software will choose where it's best to put the approach movements. So to switch that feature on, under link we say use ramp. So that now has produced a helical ramping into that part. The other retractions and entries that you see here, the retracts are done at feed rate up to a safety distance, and then up to rapid, and then the plunging is done at areas that have previously been machined, so we don't need to apply any of the helical ramping to those positions. We go into the simulator, and we'll use the defaults for determining the stock which is shown in the simulator. In other videos you'll see that you can bring in your own stock, or you can bring in the part and place the toolpath on top of that. So we're now ready to run the simulator. The stock is shown as the extents of the XYZ toolpath. So if we run that toolpath, that's the helical ramping, and now the adaptive machining. As you can see, the software is constantly adapting the toolpath to suit the stock which is left, such that it's not cutting the full width of the tool or even the radius of the tool. Okay, so you can see the effect in the corner here, where it's applying just the tool offsets to make sure that the tool load remains fairly constant all the way through. Okay, so that's that.